Differentiating the product of two functions. Our objective in this lesson is to differentiate the product of two functions. Let's consider the following two functions. F of x equals 2x and g of x equals x cubed. If I take the derivative of f of x, f prime of x, I get 2, and the derivative of g of x, g prime of x, I get 3x squared. Let's take the product of f of x and g of x. That will be f of x times g of x, which makes 2x times x cubed, or 2x to the fourth. If I then take the derivative of that product, the derivative with respect to x of f of x times g of x, that will be the derivative with respect to x of 2x to the fourth, which will be 8x cubed. Let's take a look at the product of the derivatives, meaning f prime of x times g prime of x. F prime of x times g prime of x is 2 times 3x squared. Multiplying those makes 6x squared. Notice that the derivative of the product, 8x cubed, and the product of the derivatives, 6x squared, are not equivalent. It is absolutely not true that the derivative of the product equals the product of the derivatives. Absolutely not. So instead of trying to do that, we have the product rule. The product rule tells us that the derivative of the product of two functions, or f of x times g of x prime, is f of x times g prime of x plus f prime of x times g of x. That needs to be committed to memory. We can think of it as one function times the derivative of the other function plus the derivative of that first function times the other function. In Leibniz notation, the derivative with respect to x of the product f of x times g of x is regular f of x times the derivative with respect to x of g of x, the other function, plus the derivative with respect to x of the first function f of x times the regular g of x. Either way we look at it, we're using this product rule. For short, I like to say f g prime plus f prime g. Every time I have a product and I need to take the derivative, I jot that down as a reminder. Let's try this example. Find the derivative of each function. Number 1, y equals the quantity 1 plus x squared times e to the x. Now I notice this is a product of two functions of x. So I remember to use the product rule, and I'll jot that down, fg prime plus f prime g. The f and the g just refer to the two functions. I could call this first function f and this second function g. So my derivative of y with respect to x is equal to f, the first function, just how it is, 1 plus x squared, times g prime, the derivative of the second function, which of course is the easiest, e to the x, plus the derivative of the first function, f prime, which is 2x, times g, the second function, as it is, e to the x. Now that is a perfectly acceptable answer. However, sometimes we'll see this factored and cleaned up a bit. So this is also equivalent to factoring out e to the x and getting 1 plus x squared plus 2x. Also an acceptable answer. But we can factor this further. If we write this in standard form, x squared plus 2x plus 1, we'll be able to factor that so our answer can look even cleaner, e to the x times x plus 1 quantity squared. In number 2, we have f of x equals 3 times the quantity 1 plus x squared. Now, of course, this can be considered a product of two functions, the first function being 3 and the second function being 1 plus x squared. But the first function, being 3, does not have an x in it. Instead, we can think of this as just our constant multiple and not needing a product rule, just thinking of our constant multiple rule, which says when we take the derivative, or in this case, f prime of x, the constant multiple gets multiplied to the derivative of the function that's sitting next to it. So really, all we have to worry about is the derivative of that function that has the x in it, which is 2x. The 3 hangs out while we take the derivative of what it's multiplied to. That's our constant multiple rule. While this is an acceptable answer, of course we can clean that up. 3 times 2x is 6x. So just because we know the product rule doesn't mean we always use it when we see a product of two things. We want the two things to be a product of two functions that have variables in them. And this 3 is just a constant multiple, so let's not waste our time on the product rule. While it would work, we want to be as efficient as we can. Now in the third example, f of t equals 3t times the quantity 1 plus t squared, we do have a product of two functions that both have variables in them. However, another approach instead of using the product rule would be to distribute the 3t. That doesn't mean we can't use the product rule. This is just another approach. So f of t can also be written as 3t times 1, which is 3t, plus 3t times t squared, which is 3t cubed. Now I don't have a product of functions, and I don't have to worry about a product rule. Now I'm going to write the derivative f prime of t, which is the derivative of 3t, or 3, plus the derivative of 3t cubed, which is 9t squared. And that's it. Often, when we're taking the derivative, we want to think about what is the most efficient method we can use.